Hello dear students, in today's video we are going to discuss about the first activity that is described in the chapter 1, chemical reactions and equation. So here in my hand I have got a piece of magnesium ribbon. So magnesium, as you know, it's a metal. So as you observe here, you can see a whitish dust has been a layer of magnesium oxide has been formed over this piece of magnesium. So before burning this particular piece of magnesium ribbon, we need to clean the magnesium ribbon in order to remove this magnesium oxide layer. So that we can use sandpaper. So after all removing magnesium oxide layer, so it will be easy for burning it. So now let us try. So actually in this chemical reaction, so what we are going to do is, see here magnesium, so when you burn it, so magnesium ribbon will react with the oxygen present in the atmosphere. So as a result, you will see a dazzling white flame. You will see a dazzling white flame, and this is an observation. Keep in your mind. You will see a dazzling white flame along with the formation of magnesium oxide. You can see. So I am going to collect that ash that has been formed here. So this is an example of combination reaction. So here what is happening? Two things, two reactants, magnesium ribbon, magnesium metal combining with oxygen so as to form the product magnesium oxide. So magnesium and oxygen, these are the reactants, and they react to give magnesium oxide, which is a single product. That's why it is known as combination reaction. So here actually what happens, two reactants combine to form a single product, and such a reaction, that is known as combination reaction. I hope you understood. So here I have collected that ash, which I will show you. So this ash, this is called magnesium oxide. Its formula is MgO, magnesium oxide. Dear students, in this video we are going to see another reaction. So that is the so formed magnesium oxide that we have collected in a watch glass. So now we are mixing it with a little amount of water. So what is happening here? The magnesium oxide MgO that is formed. So that is now getting mixed with water, H2O. So here what is the reaction? Magnesium oxide now little bit soluble in water. So magnesium oxide reacts with water so as to form magnesium hydroxide. So it has been formed over here. So magnesium hydroxide, how we will test whether it has formed or not? Magnesium hydroxide, it is actually a base. So I have got a red litmus paper in my hand. So you can see as I touch this particular solution, so you will see the color change. It will change to blue color. The red litmus paper will change to blue color. I can show you. Now the color has been changed to blue color. Here this part you can see the red color of the litmus paper. Is it? The red color of the litmus paper. The red color of the litmus paper has now changed to blue color. So from this we can understand magnesium oxide when mixed with water, it has reacted to form magnesium hydroxide, which is actually a base. Okay. So this is also an example of combination reaction. So about acids and base we will discuss in the next chapter. Hello dear students. So now we are going to see the next chemical reaction, next type of chemical reaction, that is known as decomposition reaction. So in this video we are going to try out a chemical reaction in which a compound called copper sulfate, the decomposition of copper sulfate. See here actually what is the color of, you observe the color of copper sulfate. The color of copper sulfate is blue. I will show you somewhat closer. Observe the color of blue copper sulfate. So now I am going to heat it. So actually what is decomposition reaction? Decomposition reaction is actually just opposite to that of combination reaction. Combination reaction, here two reactants combine to give a single product. But in this situation what is happening? A single compound that breaks up into two or more substances. So it will take a little bit time. So now we are heating the copper sulfate crystals. So it's a tripod stand, it's a burner. So I am keeping a wire mesh over this, and I am placing this watch glass over this wire mesh. So in the watch glass I have taken blue color copper sulfate. See now I am heating it. So it will take a little bit time. Somewhat bluish in color, so now it has got some pale blue color, and also at the same time you can see some white powders has been formed over here. So actually copper sulfate crystals has got 5 molecules of water associated with it. So while you heat, what is happening? Copper sulfate crystals decompose in order to lose these 5 molecules of water as water of crystallization, so it will get evaporated. So once the copper sulfate crystals loses its water, so what happens? Its color will change back to white. So you can notice that. Here you can see the blue color copper sulfate crystals has been turned to white color. You can notice that some big lumps were there, so that couldn't change the color. So in this reaction, copper sulfate crystals, actually it was having 5 molecules of water of crystallization associated with this particular crystals. So while you heat, what happened? The water has been evaporated. Again you can see, suppose if you moisten this particular crystals again, that means if you add little bit amount of water again back to this white powder, here you can see the color. Now the crystals are gaining the color. Can you see that? So these crystals are now regaining the water molecule. So the color is now turning back again to blue color. So the copper sulfate crystals, it has regained its color. So this is hello dear students. So one more example for decomposition reaction that we are going to see today. That is, here I have got iron sulfate or ferrous sulfate crystals. So you can see over here, it has got green color. Can you see that? Now I am pouring it into a test tube. So this is also an example of decomposition reaction. Here ferrous sulfate, FeSO4, ferrous sulfate crystals, which are green in color. So what will happen? So when you heat this, as here we can see the color change. the best observation that you need to notice here is the color change. The previous video we have seen that blue color of copper sulfate has been changed as a result of heating. So here also you can see the color change. So when you heat, also you remember that while you heat the test tube using a Bunsen burner, so you need to keep the mouth of the test tube facing away from your face. So when you heat ferrous sulfate crystals, you will notice that the green color will slowly change to a reddish brown due to the formation of ferric oxide. Ferric oxide, you can see that color change. Now it has lost its color. The green color almost lost. You can also smell the burning sulfur. So for that you need to bring the mouth of the test tube somewhat closer to your face and simply waft your hands above the test tube so as you can get the burning smell of sulfur. It is due to the formation of sulfur dioxide. So actually I took a very small amount, so there will not be much evolution of that gas. It will produce a burning sensation. So see, you can see here a little bit gas has started evolving. So at the same time we can see, so ferrous sulfate crystals, it has also got water of crystallization with it. So you can see the boiling tube. So it contains, so in the inner walls of the boiling tube you can see that water droplets have been hanging there. Okay, so that indicates that with the one molecule of ferrous sulfate crystals, or one molecule of ferrous sulfate, 7 molecules of water has been attached with it. So it is chemically combined with it. So when you heat, what happens? These water of crystallization, water molecules will first evaporate out, and thereby, so you can see these water droplets, it has been cooled. I mean, it hit with this particular part and has been condensed over there. And again you can see the color of the green color of the ferrous sulfate has been changed to somewhat reddish color. Color has been lost. And this decomposition reaction, which is carried out with the help of heat energy, so it is known as thermal decomposition reaction. So this particular, so the decomposition reaction which is carried out with the help of heat energy, that is known as thermal decomposition. You can see slight brownish color, not that much because of presence of water also. You can see that color from green has been changed to somewhat slight brownish due to the formation of ferric oxide.